see what the last thing they talk about is. Oh, and more simple machines. There you go. So yeah, check those out. Those will give you a better, deeper understanding of what it is that you need to know, and rather than surface learning, you can understand it a little bit deeper. Also, another thing that you should check out, there's a video that I posted on there called, where is it? Calculating gear ratios. We are going to get into that, so you'll need to make sure that you're aware of that one as well. And if I go to my notes page here, here's how I want you to do this. As you can see, I've embedded the videos in the notes page as well. So these basically just link you to the Google Classroom and take you to the Google Classroom, showing you the different videos that I recommend you check out. Now you can do it a couple different ways. You can go straight to the textbook. Let me open up the textbook here for a second. Textbook is right there. And you can read through the textbook and follow along with your notes and answer those questions as you go. So what is a lever or a lever that keeps on lifting? What allows it to keep on lifting? And it gives you a page reference. So you can do that. You can fill those things out. And if you go here, you're going to see, okay, well, here we are on page 285. Oh, look at this. The lever that keeps on lifting. You're going to go and you're going to read a little bit more about the winch. However, if you go back to your notes page, it's going to ask you what allows it to keep on lifting. So you're going to have to do a little bit more than just put down here winch. You have to kind of look into it and see, well, what is it that allows that type of lever to keep on lifting? And it's pretty straightforward, but I want you to do a little bit of digging, a little bit of reading into that. There's not a lot on YouTube about how winches work, at least as it relates to our particular curriculum. So the textbook is going to come into play here a lot. Name 5 everyday objects that use a wheel and axle. If we go back to our textbook here, here's our wheel and axle. We can see a few everyday items right here using a wheel and axle. But you're going to need to look around and maybe find a couple more that that would work as well. So let me just pause this for a second. Never mind, I'm just going to keep on going. I just didn't like that thing covering my face, but that's only when okay, just kind of learning as I go how to do this stuff. Let's move on. All right, so I know one of the questions in your note guide is also, just like a lever, wheel and axle, describe which cycle is likely going to be harder or easier to pedal. Let's go back to that picture here for a second. So we have the tricycle here with the clown and the pie, then you have this big wheel bicycle. Think about this. Which one is going to be easier to pedal? And what type of advantage might one give over the other? And this kind of, if you think about it in terms of like you're a mountain biker, you have certain gears that are a lot harder to turn, right? And then you have certain gears where it's much easier to turn, but you give something up for the easy type of pedaling and you give something up for the hard type of pedaling, right? There's something that's always lost depending on what it is that you choose. It's very similar. One of these bikes is going to be much harder to pedal than the other one. Which one is it? But what other type of advantage do you get out of the one that's maybe harder to pedal? So compare that to your own experience on a bicycle. It should be fairly easy for you to understand that. Let's go over to the note guide again and see what our next question is. So what is a gear? Let's go back to our PDF. There's a couple things here to look at. We have a series of gears here, 3 gears, and we have 2 gears. We have what is called a driver gear, and we have the follower gear. And based on this and seeing how this is attached to a pedal or a lever of some sort, this is going to turn in one way, this is going to turn in another way. The one that is the initial turning gear is called your driver gear, and the one that is connected to the driver gear is called the following gear. Notice the direction that these gears turn. So in order to get your driver gear to turn the same way as the other gear, you're going to need to insert a 3rd gear in between. So you see this is traveling clockwise. We put in a follower gear here, which turns counterclockwise, which in turn turns the next gear, which is connected clockwise. So driving gears, following gears used oftentimes in simple machines. Moving forward here. Yeah, I know we're kind of condensing this and making it as simple as possible here for you. All right, we have a wheel and pinion, which is gears in contact. One's traveling one way, one is traveling the other way. And then we have a chain and sprockets. Now, you should probably recognize the chain and sprockets as something that you use commonly. Now think about the way that the gears turn. What does that chain do? How does that change things? And imagine that those two gears are touching and the teeth are intertwined and they're turning like that. That changes the direction, but you insert the chain and now the direction of your driver gear and your follower gear now it remains the same. So that's really a useful thing for something like a bicycle, but I'm sure you figured that out by now. Let's keep on moving here. All right, so this part right here, this is where we learn how to calculate speed ratios and things like that. Now, I will do a separate video if needed, but I'll also be doing some YouTube Live if you have questions about this, but I really need you, because there is a great video right here on calculating gear ratios. It's a 5-minute video that's going to show you how to calculate those gear ratios. I will be creating a Google Doc where you'll be able to calculate those gear ratios and show me that you understand how to do that, similar to what we did recently with the calculating mechanical advantage and calculating the calculating work. So be prepared for that. But again, great video, very clear, very concise, easy to understand. Guy's voice is kind of boring, so is mine right now, but you know what? It's very clear and it's easy to follow. So check out that video for when you get to that part there where you're asked to calculate, calculate gear ratios. All right, pulleys. The last thing we're going to talk about now in this particular topic is pulleys. So there's a lot of uses for pulleys. They can create a mechanical advantage, but sometimes it's just for convenience. So if you look at this particular picture here, this gal here is doing a leg extension exercise, which she's able to sit in a nice comfortable position and extend her legs up with the resistance pushing against her legs to work her quadriceps muscles. Now, this is simply for convenience. She's not gaining a mechanical advantage, because really, if you're lifting weights and trying to get stronger, why would you want to gain a mechanical advantage? But what's happening here is there's this push up, and then there is the pull from up top. So there's a change of direction, which makes it more convenient for this person here. This individual is able to sit in a more comfortable position and work out a muscle group that might be more difficult to work out if there weren't a change of direction. Now that's just a fixed pulley system here, and you see a picture here of a fixed pulley system, and here it talks about your mechanical advantage being 1. And of course we talk about mechanical advantage of 1, meaning there's no mechanical advantage, but there's no change in speed either. But what we have is a change of direction, which could be convenient, as we talked about before. Now this particular type of pulley is called a movable pulley. So if I were to pull up on this end right here, this pulley also is going to move. Now with a movable pulley, look at our mechanical advantage. We have a mechanical advantage of 2. So keep that in mind, that a movable pulley, there's pros and cons to both, but if you're looking for mechanical advantage, a movable pulley, if there's just a one-wheel system, creates a mechanical advantage. Now, we can supercharge pulleys, and that's when we get into things such as a block and tackle or a compound pulley, and you can picture one right here. So they usually have very long cables that weave around several different pulleys in order to create a mechanical advantage. So you can think about different uses that those might be used for, but if we look at this particular block and tackle right here, you can see that it has a mechanical advantage of 4. And basically the way to calculate that's fairly simple. You can look at the number of pulleys involved in that situation. There's 4 pulleys, therefore create a mechanical advantage of 4. So that's it. That's pretty much it for topic 2. Straightforward. What I recommend is go through the note guide, be as thorough as possible, and then I'll give you some practice questions to calculate gear ratios as you would with your bicycle. Yeah, that's basically it. Hopefully you found this helpful, and we'll catch up with you later. Again, tune into my YouTube lives. I'll do those on Tuesday and Thursday at 1 p.m. Subscribe to the channel so you're notified in case you forget. See ya.